Okay, 9.1 had us say, hey, if something's a parallelogram, and let's remember the three things. If it's a parallelogram, opposite sides are congruent, opposite angles congruent, diagonals bisect each other. 9.2 is going to have conditions. That means if something's there, for instance, in this case, both opposite sides are congruent, then we're going to prove that it's in fact a parallelogram. So there's going to be some more proof. Please don't just rush through this. Think about what we're doing. All right. So the very first thing we're going to do is we're going to prove that a quadrilateral is a parallelogram given certain items. In this case, if both pairs of opposite sides of a quadrilateral are congruent, then we're going to prove that it has to be a parallelogram. Let's go ahead and do that. All right. They have given us that AB, I can see it right here, and CD are congruent, and AD and CB are congruent. Now we're supposed to prove it's a parallelogram. So here we go. First thing we got to do is draw a diagonal DB. So I'm proving it. And we can already see we're probably going to go with side, side, side somewhere on here, right? So we got these two guys that are given. And let's see. All right. So we got DB is congruent to DB. All right. That's the reflexive property. And then we've got those two sides they gave us right here. AB is CD, and CD is congruent to CB. We're going to say given. Right? And then we got the two triangles congruent. And we're going to say, hey, you know what? That's side, side, side. All right? And once you prove side, 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 you can prove parts. So let's see if we're proving parts. ABD right here is congruent to CDB over here. And ADB right over here is congruent to CBD. Alright, so we proved those parts. And since they're in corresponding parts of those triangles, we say corresponding parts of congruent triangles are congruent. And then once you have these, right, you can say, hey, they're parallel. Because if these alternate interior angles are congruent, right, then you know this side's parallel. And if these are congruent, you know that this side's parallel. So we're going to say converse of the alternate interior angle theorem. We're going to say it backwards. Instead of, hey, if they're alternate interior angles, if they're parallel, they're alternate interior angles. We're going to say if those alternate interior angles are congruent, then they're parallel. And then once we got those alternate angles, it says it's a parallel, and we're going to say definition of parallelogram, which they might have put the theorem that we did on the last one, but that is what a parallelogram is. Well, there's the first one. All right. I'm going to go ahead and fill this thing right here. If one pair of opposite sides of a quadrilateral are congruent, and parallel, then the quadrilateral is a parallel. So that's the next one we're going to prove. So we proved it if both opposite sides are congruent, and now we're going to say, hey, if one pair is congruent and they're parallel, then it's a parallelogram. That's our next thing to do. I'll talk to you soon.